Hello, everyone. My name is Jonathan Miller, and today I'll be presenting my case study on the BP Texas City refinery explosion in 2005. The tragic event remains one of the most catastrophic industrial accidents in U.S. history. On March 21st, 2005, a massive explosion occurred during the startup of the isomerization unit at BP's Texas City refinery. The explosion killed 15 workers and injured approximately 180 others. What makes this event especially significant is that it was completely preventable. In this presentation, I'll discuss how the system was intended to work, what went wrong, the root causes, and the lessons learned to prevent future tragedies. The disaster began with a chain of critical failures that unfolded during the unit startup. First, the raffinate splitter tower, which separates hydrocarbons, was overfilled far beyond safe limits. The operators lost control of both pressure and liquid level inside the tower. Second, the overflow was routed to an outdated atmospheric blowdown drum instead of the flare system. This design allowed hydrocarbons to be vented directly to the atmosphere. Third, as the blowdown drum overflowed, it released a large vapor cloud that spread near ground level. And finally, the vapor cloud found an ignition source. It is believed to be an idling diesel pickup truck and detonated with massive force, destroying nearby structures. This chain of events shows how a simple procedural deviation can cascade into a catastrophic system-wide failure. In a properly functioning system, the startup process should have been tightly controlled through validated procedures and automated safeguards. Operators should have been guided by strict startup limits, warning alarm systems, and continuous level monitoring. Automated safety instrumented systems should have been placed to prevent tower overfill, even if human error occurred. Most importantly, all pressure relief should have been routed to the flare system, not to an atmospheric vent. A flare safely burns excess hydrocarbons, preventing vapor accumulation at ground level. And finally, effective communication and shift handover should have ensured everyone understood the system status before startup. If these had been functioning correctly, the explosion would have never occurred. Investigators found failures on every level: organizational, technical, and human. At the organizational level, BP's corporate culture emphasized cost cutting and production goals over process safety. The process safety management program lacked rigor and oversight. Technically, the plant relied on an obsolete blowdown drum that vented hydrocarbons directly to the atmosphere, a design that should have been replaced decades earlier. Human factors are also major contributors: faulty instruments, fatigued operators, poor training, weak communication during shift changes, all combined to create the perfect storm. The primary root cause was organizational failure, a weak safety culture that ignored warning signs. Technical flaws and human errors simply made the situation worse. The detailed analysis revealed several critical breakdowns. Procedural errors. Operators deviated from written startup procedures, and a key drain valve was left closed, which contributed to the tower overfilling. Design deficiencies. The blowdown drum vented hydrocarbons straight into the atmosphere rather than the flare system. This violated modern safety design standards. Poor siting. Contractor trailers were placed dangerously close to the process area. All 15 fatalities occurred in or near these trailers. Human performance issues. Workers were on 12-hour shifts, leading to fatigue and slower reaction times combined with faulty instruments and poor training. The operators had little chance to respond effectively once the system went out of control. The result was total system failure, technical, procedural, and human. The human cost of the tragedy cannot be overstated. 15 workers lost their lives, most of them contractors, inside nearby trailers that should have never been placed in the hazard zone. Another 180 people were injured, and the total financial impact exceeded $2.1 billion in settlements, fines, and reconstruction costs. The Chemical Safety Board concluded that the disaster was caused by organizational and safety deficiencies at all levels of BP Corporation. It's a somber reminder that behind every incident statistic are real people whose lives were cut short because safety took a backseat to production. Lessons learned. Following the incident, the Chemical Safety Board and Baker panel conducted extensive investigations. Their findings led to sweeping recommendations across refining industry. Build a stronger safety culture where safety is valued at every level of the organization. Eliminate atmospheric blowdown drones and replace them with inherently safer flare systems. Strengthen management on change and startup procedures to ensure overfill prevention. Expand training and process hazard analysis using realistic simulators for startup operations. The regulatory response included major updates in API RP 521, stricter trailer seating standards, and enhanced OSHA enforcement on process safety. These changes have since helped similar trailers, but only companies stay vigilant. In conclusion, the BP Texas City explosion was not a mystery. It was a predictable and preventable outcome of systematic failure. Outdated equipment, poor communication, inadequate training, and a weak safety culture all contributed to the disaster. The key takeaway is that safety systems must work together as an integrated whole. Engineering design, management oversight, and work competency are all essential. To prevent the next disaster, design system to be inherently safe, eliminating hazards wherever possible. Implement safety guards to prevent human error. Embedded safety culture into every decision from the control room to the boardroom. 20 years later, the lesson from Texas City still remind us that safety is not a cost, it's a commitment. Thank you.